Hey, everybody. Thanks for joining today on Thursday, May 29th, 2025. My name's Erin LeDell. I'm the chief scientist at Distributional, which is an AI testing company. And I'm here to talk to you about model evaluation today. And so the theme of this talk is, sort of the transition or differences and similarities between traditional ML and GenAI with respect to model evaluation. And probably a lot of you are familiar with, the concepts in traditional ML. It's been around for a very long time, but I will go over that as well, and then introduce kind of, some new things that are unique to GenAI. And feel free to write comments in the chat, and if you want to introduce yourself, that's also fine. And if you want to say anything about your experience with GenAI and if you're new to it or you're using it, experimenting with it, or using it in production, that would also be interesting to know. So there's 3 sections. So first, I'm just going to talk about, traditional ML, eval and benchmarking. I'll go over like the differences between those 2 words. And then introduce kind of like the concepts and like the sort of the new architecture of modern AI applications. And then we'll talk about how to evaluate those. And by modern AI applications, I mean specifically AI that's using large language models or GenAI aspects in the pipeline. Okay, so eval and benchmarking in ML. So this is not new stuff. This is just going to be an overview so we can make a contrast. So one thing to look at is sort of what are the properties of these systems? So how do they work? Like, what are the features of them? Like, all of this stuff influences how you would evaluate a system. So kind of the main thing about machine learning systems is that they're usually deterministic, which means you put the same input in, it will yield the same output. There's some exceptions to that rule. Like, there's some algorithms that use multi-threaded stochastic gradient descent and other kind of sort of technical pieces which will not let you get exactly the same output. But for the most part, a lot of the algorithms used out there, you can set a seed and you get the same output. And so that makes everything a lot easier. And so one assumption that you have about a machine learning system, if it's deployed in production, is you want the distributions of the feature data or the input data to remain consistent over time. And so if it does shift, like, you might need to be retraining your model. And so this is like a normal thing. Like, distributions of data do shift over time in many cases, and that's why people retrain their models. If it's like once a month or once a year or daily, there's you have to figure out what the cadence is and potentially retrain your model. Or if you're using some kind of like online learning model, you can like add and update the model without retraining the whole thing. So another thing that you want to look for is like I guess we're starting to talk about, hinting at evaluating this system. So you would want to monitor the input and feature distributions over time to make sure that's staying consistent. And if it's not, you retrain. Also, you can just look at the prediction distributions. That's something you should also look at. And you should definitely look at that if you're not looking at the other. And that's, machine learning models in the traditional sense, like, have one column or output that you're trying to predict. That could be numeric, it could be categorical, so like multi-class categorical or binary categorical. So that's like one thing that you basically have to look at, and it's pretty straightforward. So another thing is that a lot of the metrics that we use, what I would call sort of off-the-shelf metrics, so metrics that you can get in any kind of scikit-learn package, like that type of thing, AUC, RMSE, etc. Those are pretty well understood. Like, we know what they mean, we know how to calculate them. there's some, question of how do those map to actual business problems and business objectives, but that's a different question. But basically, everyone's using the same, metrics. Like if you have a binary classification algorithm, you're probably going to use AUC or maybe, log loss or something like that. But there's some consistency and norms around doing that. One comment in the chat from Ken. Hi, Ken. Nice to see you. I can make the slides available. We can just post a link on this LinkedIn Live page if that's a possibility, or maybe on just on LinkedIn. We'll try to get the slides ready for you, so you don't feel the need to take screenshots or anything if you don't want to. Okay. So, and then in traditional ML, we have like supervised machine learning, classification and regression. We have unsupervised, which is things like clustering, dimensionality reduction, etc. I'll kind of maybe focus more on like supervised ML because that's, it's just more straightforward, the metrics. So just terminology. So in ML, like now in the modern era of GenAI, we talk a lot about eval. It's not a well-defined term. And in the olden days in machine learning, we would maybe just say model evaluation. I don't know if people were saying eval back then, but we can talk about it. It's same thing. So model evaluation. And so model evaluation is something that you do on, evaluate a model on like one or more data sets. So if you just have a specific application that you're building with a specific purpose, you're trying to predict, housing prices or something from Zillow listings, whatnot, you would just, evaluate maybe different model configurations on the same data set. But if you're trying to get a like sort of a broader understanding of how a specific algorithm or even an algorithm with certain parameter settings works compared to something else. Let's say you want to compare two different implementations of gradient boosting machine, like light GBM versus XGBoost or something like that. So you would want to collect a large number of data sets with hopefully like a diverse set of properties, like having different sizes, different types of data, like you might want to have numeric features, a lot of missing data, a lot of not missing data. You might want to throw in some high cardinality categorical columns, like a lot of like whatever you think could like challenge the algorithm, you want to have like a good representation of that. So that's what we call benchmarking. And that's how I would distinguish the word eval from benchmarking. So what else can we say about that? So the evaluation metrics, like I said, are well understood. They're pretty straightforward. And if you're doing regression, there's some subset of metrics that you would use in that case. There's not necessarily like a correct metric for each task. Like regression, there's a number of different regression metrics that you can use. You can also map those to like business objectives and do more complicated optimization and things like that. So one thing that I'll mention, because this becomes an issue with GenAI, is like computing an eval metric is very cheap in the sense of like compute. It's like basically nothing. So to compute like the AUC or the RMSE or whatever on a machine learning, like a whole test set even is extremely cheap. And that's great. But, once you start benchmarking and you're doing, let's say you have, 5 different algorithms that you're benchmarking, and you want to do like 10-fold cross-validation on each of that and like across like 25 data sets, like that starts to become expensive. So these are just some things to keep in mind. Another thing I'm going to introduce in a second is like offline versus online evaluation. So I'll go to that. So just in case you haven't seen a benchmarking framework before and what that might look like, before I move on to the online versus offline eval, this is a benchmark that I co-created with some other AutoML people back when I was doing a lot of AutoML. It's called the AutoML benchmark. And the things that you would kind of typically look at in a benchmark are not just the performance metrics. So, you might look at some performance metrics, AUC, log loss, RMSE, et cetera, but you also might look at training time, inference speed. Inference speed is obviously very important if you plan to productionize the models. And then a lot of times these things are in contrast with each other. So if a model has a very high AUC, it's a very good model, you might have achieved that, that high accuracy because the model is like super complex, and that might slow down the inference speed. So there's sometimes trade-offs. So you don't want to just look at one metric alone. You need to put some context in there and kind of understand how these things relate. So like there's something called Pareto frontiers where you can sort of map one metric against the other. And usually if they're competing, that's a good thing to do. Okay, so back to sort of eval, online versus offline. So offline is just when you're doing evaluation in the development or deployment environments. So you would do this when you're first trying to select the model, train the model, or anytime you want to upgrade the model, you want to, in an offline manner, just test it on your test sets, or what we call the golden data sets now in GenAI. So, and benchmarking is also an offline sort of thing. So online is when you have a model running in production and you're actively monitoring it and like maybe subsampling from the user input and computing different things on whatever metrics you have. So one thing that we look at in particular is like drift detection. So you want to kind of revisit what we said before, where we're looking at like making sure there's not like data drift, because that would indicate that you need to probably retrain your model. So, and it's good to know, because otherwise your model's working on data that it wasn't trained on, and it will have undesired effects and not be accurate. So that's what online versus offline is. So yeah, moving on. So offline, okay, we kind of went over this. This is essentially everything that I've said sort of summarized before. This is just a couple more examples of different metrics. And so we don't need to spend a lot of time on that. But let's go to online. So again, we have, this would be something kind of instrumented in an MLOps system that or you maybe build something yourself, but like this is basically what MLOps systems do, or one of the functions of MLOps systems. So you can also do things like A/B testing would fit under online eval. If you're doing it live, if you're doing it, sort of compare this model to that model, that can happen in development. But like if you're deploying two different versions of something, like they do this on online platforms all the time. Shadow testing is where you have a feature where you have two different models running and they're both consuming like the live user data, but one of them is sort of interacting with the users and one of them is not. And then another thing that can happen that's weird with online eval is like model predictions do influence like the data that you will later see. So there's kind of this thing where you make a prediction and that might change the behavior of like the future predictions. And so there's kind of this weird feedback loop that you need to be aware of. Okay, so that we covered traditional ML. So now how does this kind of change? So what we have these days is we have a lot more complexity. So here's just kind of a simple example to start. Let's say you're trying to, you're some kind of legal tech firm and you're building some process to, maybe go on the internet and download like new legal cases or something like that. Could be anything. This is just an example. So some kind of setup where you have a RAG system. And if you're not familiar with RAG, that's, retrieval augmented generation. It's sort of LLMs plus some like a corpus of data that has like correct data in it that you want it to use in your responses. Trying to summarize that very quickly is hard. And so let's say you have a process where it goes out, it collects new documents, it like maybe strips out metadata about like these documents, and then it's using an LLM to do that. Like maybe it's, where is the jurisdiction of this thing? What is the date? Like that type of thing. You're using the LLM, you have some prompt that's like strip out X, Y, and Z. So that could just be one piece of like an ETL processing pipeline. So then you might even have another LLM that would be involved in the RAG component. So there could be many LLMs like within one application. So things start to get quite complicated. So just to kind of summarize like what I would call the properties of modern AI systems. So here's 3 things I think are really important. So one is what we just sort of hinted at before. So AI applications are multi-component systems. It is true that machine learning applications are also configured in a multi-component sense, but it seems like there's a lot more going on with modern, like let's say modern GenAI systems, especially once you deal with these other 2 points. So for example, the vector databases are used quite often, especially like in RAG systems, which are very popular way to use LLMs these days. So if you, let's say, update your vector database with like new data coming in, like that changes things and it could affect your LLM's responses. So you need to know like there's all these different points that feed into the LLM, and then the LLM can also change, and then that might be feeding into like other more stationary type things. And there's a lot of interacting components is basically the theme. Second point is that AI applications are non-stationary. So like even if you don't change the code, like let's say you didn't upgrade your GPT 4 point whatever to the next one, they can still shift. So that is different from the deterministic sort of traditional ML. So another way that they can experience this non-stationarity is that users might be using your system in like a very different way than they did previously. Like if it's a chatbot, like if there's some kind of event that let's say it's a chatbot, like about, it's like a city chatbot. So the city of whatever has a chatbot where you can get information about visiting the city and whatever. Let's say there's like some big event that happens in the town that weekend. All of a sudden people are asking all this information about this event instead of like the city. So like you didn't maybe anticipate that, and now your model doesn't know what to do. It's like maybe based on a RAG system, and all of a sudden it's like getting a bunch of questions about stuff that's not in the RAG corpus, and it's giving you like bad answers, or just like, I don't know, or I can't help you with that. So that's kind of like stuff that can happen. This causes problems. The other thing is the term I would use is that they are non-deterministic. So even with the same input, you might get different output. So that and LLMs, like even if you like, there's a parameter called temperature on LLMs, even if you turn it all the way down and like it's supposed to be the most sort of deterministic version of that, it can still give you different answers if you ask it the same question twice. So this is just a property of LLMs. It makes it very, very difficult to write tests for these LLMs because you don't know what you're going to get. So that's just one big thing. Okay, so how do we deal with that? So just quickly, there are some overlaps with, when we're evaluating a GenAI model versus a traditional ML, like the goals are essentially the same. So, is it giving me a correct answer? Like, is this harmful? Is it not harmful? Can it generalize to tasks it wasn't explicitly trained on? These are all concepts that already exist in traditional ML. You just answer them in different ways. So one that is kind of unique to GenAI is like maybe helpfulness. Like, is this helpful? So there's lots of different ways you can, I guess that could, I would say that's distinct from analyzing like the accuracy. So there's new concepts introduced because we're dealing with text-based, systems. And the other thing is like the metrics look very different. So when all of our input is text, of course, there are GenAI systems that deal with images and other types of things, but let's just, for simplicity, say text. So every metric that we compute has to have something related to text. It has to be able to take text as input. So the metrics are totally different, and if you're not used to them, you might not know what to do with them. There's different ones that are better for like long form output versus short form. Like it's a lot more nuanced and a lot more subjective. And the other thing that's extremely different from traditional ML is in machine learning systems, you can automate all of this stuff. Like I spent, 5 or 6 or 7 years doing AutoML. So all of this stuff can be fully automated. You don't have to like think about how to evaluate. You just give it the data, give it the function, it computes, you write the answer to, disk or whatnot. So that's just not how these things work with GenAI. So humans are a lot more involved because, there's not so much clarity on like when you get a text response, is it correct or not? There can be in terms of like factual based systems, RAG systems, if it's asking, what is blah, and there's a correct one answer and it either gives it or it doesn't. That is one subset of LLMs. But a lot of times it's like, summarize this document, and then it's like, did it do it correct? Is it good? Is it sort of good? How is it? In what ways is it good? In what ways is it not good? So there's a lot of subjectivity. So humans are involved in a couple things. Like one, to create these golden data sets. So these are like sort of validation data sets, like when you are in the development or deployment phases of a model. You want to write these data sets. A lot of people will automatically generate golden data sets with LLMs. That is something you can do. But typically you at least have to have a human like look over what you've come up with to see if it makes any sense. So maybe you want to have the humans like write the inputs, but maybe you could use an LLM to generate the outputs and then just have somebody kind of look over it and edit them. Or you can do like a thumbs up, thumbs down, like get that kind of data. So yeah, I think it's just a lot harder to generate golden data sets that are representative of like all the different ways that like the users could interact with the system. And it's just a more, complicated situation. So I wanted to give a shout out to a technique called EvalGen. This is just sort of a framework for sort of doing what we call alignment. So to make sure that basically like the user feedback, it's a way to like plug a human into a loop of eval, where you kind of like have somebody looking over sort of the process of evaluating. I'm just going to keep it short, but like if you're interested in different types of frameworks for doing this, this is one that I think you should look at. And then lastly, like one thing to point out is, in traditional ML, like you have typically you're looking at the predictions and like the distribution of the prediction over time. And the prediction is just one number, or let's say category, but to keep it simple, let's just say number. That's easy to look at. And there are very simple metrics that you can, check if a distribution is the same as another one. However, for the output of LLMs is not just a single number. It's text. It can be, in the case I say over here of structured outputs, it could be not text. Like if you have a prompt that's saying, give me numeric value of this or whatever. It doesn't necessarily have to be like text in the traditional sense, but there is usually like more complexity to the output. So one, you can just like take that output and compute text metrics on it, like the rouge score, the blue score, those type of things. But you can also like process that data as well and like derive other metrics on it. and then you end up with like a whole bunch of things that you're wanting to track over time. And yeah, I mean, and you might not just be tracking like the output of the LLM, like in a RAG system. Really important part of a RAG system is the retrieval step. So you might want to track stuff related to the retrieval and how that is changing over time. If traditionally it's, retrieving, let's say 20 documents, and all of a sudden it's retrieving 0 documents or 1 document, and you might have a problem. There might be some update you made to your vector database that's messed things up. So I guess one other difference, and maybe I'll just sort of end on this point, is that when we talk about eval in like the modern AI sense, you're really evaluating a whole system. It's not just like the model itself, because these things are just much more complex. And I think traditionally we would just kind of talk about model evaluation on the single model, but not so much on the whole machine learning system. Whereas now it's just a lot more, there's just a lot more going on, and it's not just looking at the output of the LLM, it's looking at all these other different pieces as well. So as you can see, there's just a lot of complexity that gets added here. And yeah, that's pretty much it. And so let's see. Yeah, I don't see any questions in the comments. If you want to put anything in there now, feel free, but we will share the slides. And if you'd like to connect, you can find me on LinkedIn. And I should also mention Distributional is a company that does AI testing. And one of the things that we do is we test for these distributions, these complicated, basically the last slide is like, these things are completely complex. You need to test them over time. You need to check that things aren't changing in all these different ways. It's not as simple as like, I have my golden data set, I'm going to test it, deploy, I hope everything's fine. Things get wild. So you need to have some framework that is running in production on these systems if you have them running in production. And anyway, the talk is not about distributional, but we do provide a solution for that. And that is why I'm here. So thanks.